Hi guys, so here are the 4.5 and 4.6 notes that you'll need to complete the two worksheets that I handed out today. And it's a little bit more about congruent triangles, which we talked about the other day. What we said about congruent triangles before is that congruent triangles have all three sides in common and all three angles in common. And you would probably think that in order to convince somebody that two triangles were congruent, you would have to show all six of those things were congruent, all the angles and all the sides. In reality, there are some shortcuts that we can use where we only have to prove two or three things are the same between two triangles, and then we can stop there. We don't have to show all six things are the same. And so on this page are the shortcuts. There's 5 of them. This first one that says SSS stands for side, side, side. So basically, if you can show that two triangles have all three sides in common, then you don't need to show anything about the angles. You can stop there. There's no other option but that those two triangles are congruent. So if you can show that these two triangles have that side in common, that side in common, and that side in common, then it is for certain that those triangles are congruent to each other. SAS stands for side, angle, side. And so with this, these are called postulates, by the way, these 5 things. With this postulate, we just need to show that a couple of sides in an angle are shared between two triangles, that they have those in common, and then we can say that the triangles are congruent. The only thing here is that the sides and the angle need to be in a very specific order. So we've got two sides that we need to show are the same. So if we can show that two triangles have two sides in common, we're almost there. We need to show then that the angle in between the two sides is the same between the two triangles. So it must be the angle that's immediately between the two sides, the angle that's formed by those two sides, not one of the angles that is outside of the two sides. So it's got to be directly in between. And that is why it's called side, angle, side, to represent that the angle is in between the two sides. So those two triangles have to be congruent to each other. Now the next postulate, ASA, stands for angle, side, angle. And this is kind of like SAS. If we can show that two triangles have two angles in common and a side that's immediately between those two angles, then those triangles must be congruent. So if we've got two angles congruent between these two triangles, and I can also show that the side that's in between the two angles, or the side that has the angles at each end, if I can show that that side is the same between the two triangles, then the triangles are congruent by angle, side, angle. And then we also have AAS, which stands for angle, angle, side. And this is for the case where we have two angles in common between two triangles, but the side is not in between the two angles like it is with ASA. So if we have the same two angles that I had in the last picture, and then either of the two other sides that are not in between the angles, those are congruent, then we have angle, angle, side. Now, there's no such thing as angle, angle, angle. So two triangles can have the same angles, but be different sizes. Their side lengths can be different, and they can still have the same angles. So angle, angle, angle doesn't quite prove that two triangles are congruent. They're similar, but not congruent. And then there's no such thing as angle, side, side. So up here with SAS, I was very particular that angle needs to be in between the two sides. If we have two sides in an angle that is outside of those two sides, it is not a postulate that we can use to prove that the triangles are congruent. There's actually, in that case, there's two possible triangles that we could be looking at instead of just one triangle that's definitely congruent to the other. There's actually two ways to draw a triangle in that case. So it's not enough evidence to show that the triangles are congruent to each other. Now, there are special names for similar postulates with right triangles, but I'm not going to bog you down with all of these other postulates. These four that I have right now are enough. And with the right triangles, all of the other postulates have counterparts that I've already shown you. So for instance, one of the postulates is leg angle. So if two right triangles have a leg in common and an angle in common, you would say leg angle for the postulate. But that would be potentially the same. You could say angle, angle, side instead because they also have that right angle in common. So I'm not going to show you those postulates so that you have to memorize all of these other things, except that HL, which stands for hypotenuse leg, is one that does not have a counterpart here. It's actually has to do with angle side side. When you are dealing with a right triangle, you can at that point use angle side side, but only with a right triangle. And we don't call it angle side side, we call it hypotenuse leg. So if we have two right triangles and they have their hypotenuse in common and one of the legs in common, they are definitely congruent to each other. This only works with right triangles. And you can see this, it looks like angle side side, which you can't use on generic triangles, but it definitely works on right triangles using hypotenuse leg. So now for the first set of examples, we're just going to look at various pairs of triangles and determine if they are for sure congruent to each other, and if so, which postulate we're looking at. So this first set of triangles, they have two angles in common and a side in common. Now, the side that they have in common is not directly between the two angles. It's outside of the two angles. So these triangles are congruent. We're going to write yes, they're congruent. And the reason they're congruent is because of angle, angle, side. Not angle, side, angle, because that side is not in between the two angles there. Now this one over here is pretty easy. We've got side, side, side. These two triangles have all three sides in common. So they are definitely congruent as well by side, side, side. Now, these two triangles, they kind of look like they're congruent, but the only thing that's marked congruent between them is the three angles. An angle, angle, angle is not a postulate that we can use to prove that the triangles are congruent. They could theoretically be different sizes and still have the same angles. So we would just write no on this one. They're not for sure congruent to each other. Then over here, we've got two triangles. They've got two angles in common again, kind of like this example up here. But this time, they also have a side in common that is between the two angles. So these triangles are congruent, but this time it's because of angle, side, angle. Now over here, we've got two triangles. This time they have two sides in common and an angle. That angle is right in between the two sides. So we have side, angle, side, which is a postulate. So these are congruent for sure by side, angle, side. And then over here, we've got two triangles, but only two things are marked on them. So they've got two sides in common here. This side is not marked, and none of the angles are marked. Here's where things start to get a little bit more interesting and stuff that you're going to be using on proofs with triangles. So something that you may have noticed here is that we have vertical angles right here. And we already know that vertical angles are congruent. So we get to add our own marks to this picture to show that the vertical angles are congruent. And now hopefully you see we have side angle side. So if you have a very compelling reason to add a mark to your picture, such as vertical angles, go ahead and do that and then see if you have a postulate. Now these two are right triangles. At first it looks like we're looking at angle side side, which is not a postulate, but since these are right triangles, we actually have hypotenuse leg. So they are definitely congruent. Now over here, we have two triangles again, and only two things are labeled. They've got a side in common and an angle in common. But they are sharing a side literally in the middle here. Whenever we see two triangles sharing a side like this, we want to mark it congruent. And the way that you do that is you just write one set of congruent marks through that side that they're sharing. Now, we have three things here. However, it is angle side side because the angle that's marked is not right in between the two sides. So even though we got to add that mark, we still don't have a postulate that proves that these triangles are definitely congruent. So we're going to say no on this one. Now over here, we've again got these two triangles literally sharing a side. I'm going to mark that. And we've got two angles marked congruent, but we still only have two things. However, we have PQ and RS marked parallel to each other, and we know that with parallel lines and transversals, such as this diagonal, that there's lots of different angle pairs that are congruent. In this case, PQR is actually congruent to SRQ because they are alternate interior angles, and since we know that the lines are parallel to each other, they must be congruent. So now we can see that we have angle side angle. And then finally over here, this bottom line is supposed to be straight, by the way. So we've got one right triangle on the left and a triangle on the right. They've got one side marked congruent. They do have the side in the middle congruent. And over here, since this is a straight line, which is 180, and we already have a right angle marked over here, or 90, well, this is 180 degrees. If this is 90, this has to be 90 over here also. So now we've got hypotenuse leg. Both right triangles, they've got a hypotenuse in common and a leg in common. So we're going to write yes, hypotenuse leg. And now finally, we have a couple of proofs to look at. And now that we've gone over that last exercise, the proofs actually shouldn't be too difficult. We're just going to add marks to our pictures like we just did, but we're going to write down about why we chose to add those marks. So what were our compelling reasons to add those marks when we needed to show that the triangles were congruent. All right, so our given here first is that RS is congruent to TS, and that's already marked on our picture for us. And we're also told that V is the midpoint of RT. Well, our first given, like I said, is marked on the picture. Our second given is not marked on the picture. And we all know the midpoint is the very middle of a line segment. It divides it into two equal pieces. So if V is the midpoint of RT, that means that each half of RT here is congruent. So let's go ahead and mark those congruent, RV and TV. And the reason that we got to add those marks is because we were told V is the midpoint, and that's what midpoint means. What we're going to write down is definition of midpoint. Now, we also get to mark that these two triangles are sharing a side. So we're going to mark that congruent. And the way that we're going to write about this in the proof is we're going to say that segment VS is congruent to segment VS. And so back when we started learning all of these reasons that we could write down in proofs, one of the first things that we learned was the reflexive property, which says that every line segment is congruent to itself, just like I've written in statement C. So we're going to write reflexive here. Now, all of my marks are on the picture, so I have enough evidence by side, side, side to conclude that these triangles are congruent. So I'm ready to make my last statement here. What I'm trying to prove is that triangle RSV is congruent to triangle TSV because of side, side, side. And now our last example here, got a couple of triangles. Again, you may already see some markings that we could add. We're given that angle S is congruent to angle U. That's already been marked on our picture. And we're told that TR, segment TR, bisects angle STU. So TR, this segment here, bisects angle STU. So this big angle here is being bisected. All right, so our angle S is congruent to angle U is already marked on the picture. The other part of the given is not. So TR bisects angle STU. Bisect means to cut in half. So if this segment is cutting this angle in half, it means it's making two smaller angles that are congruent to each other. Now, for some reason, when a segment is bisecting an angle in a triangle picture like this, people get really confused about whether we're talking about line segments or which angle is being bisected. So you have to be really careful that you've got everything straightened out when you're looking at this picture. So TR is bisecting STU. That means that I have two angles here that are congruent. It's these two angles here. And so I'm going to write about that. So angle STR is congruent to angle UTR. And the reason is definition of bisect. Because that's what it means to bisect an angle. Now, we've got that reflexive thing again. These two triangles are sharing side RT. So we want to write about that. We want to mark it congruent. So we'll say RT is congruent to itself by the reflexive property. And now if we look at our picture, we've got our three things here. We have angle, angle, side. So we're ready to state that the triangles are congruent. And that's it for the notes for these two sections. I combined them because I just wanted to get all of the postulates together and show them to you guys. So you've got a couple of worksheets to work on for homework. Do what you can in the time that you have after watching this video. You should definitely be able to do the one where the triangles are drawn and you're just trying to determine if there's a postulate that shows that they're congruent. That should take you less than 5 minutes. Then do your best on the proofs. They shouldn't be too hard. And then we'll just see how you did on Monday. Have a good weekend, and I'll see you next week.